Good morning, pirates. Today we're going to look at two important scientists and how they thought the structure of the atom existed. So we're going to start with John Dalton. So we're going back, 1803, way before coronavirus existed. And he came up with four very important findings. The first thing he came up with is that all matter is made up of atoms. Okay, you can kind of wrap your head around that. Everything we have has some tiny atoms inside of it. The second thing he said is that all atoms of the same element are the same. So what he means by that is you could have a sodium atom or a hydrogen atom, and they're very different from one another. Okay, their masses, their properties are different. And if you look at his very early on theories of an atom, here he's saying atom number one or element number one might look like that, whereas an atom of element number 5 looks like this. And they're very different from one another. So every element has its own unique atoms. The third thing he mentioned is that atoms combine in specific ratios. So for example, a common substance in your home is probably table salt. Sodium and chlorine, sodium chloride make table salt, and they combine in a ratio of 1 sodium atom to 1 chlorine atom. And that still holds true today. The final thought that Dalton had is that nothing was smaller than an atom, and that fact it was indivisible. Okay? So if you were to take a piece of matter and break it down into its final part, the smallest piece would be an atom. And that's not exactly true today, because inside an atom, as some of you remember, are subatomic particles like protons, neutrons, and electrons. So that's John Dalton's early on views of what an atom looks like. Then comes along Ernest Rutherford and many other scientists that worked with him to actually do an experimentation to test what else is inside this atom. Is it just this tiny indivisible piece, or is there more to it? Okay, so if you look at this visual, there's a lot going on here. Ernest Rutherford took this lead box and inside of it put alpha particles. Okay, alpha particles are basically helium nuclei, but what you need to know about it is that they are these positive particles inside this box. Okay, and he set up a piece of gold foil over here. Okay, now he's also compared this to shooting a bunch of bullets at a piece of tissue paper. Okay, now if you're with me, right? If we were to shoot some bullets at a tissue paper, they're going to go right through it. Okay, similar idea here. We have very heavy particles being shot at a tiny piece of gold foil. So thinking they're all going to go through, as you see here. However, if I change colors here, you will see that some of the alpha particles were deflected. So even though they were shot directly at the gold foil, some of them, hit and went on an angle. And sometimes the particles actually deflected or traveled back at the source. So there's a lot of findings here from Rutherford's experiments. Okay, the fact that most of the particles went through shows us that the atom is a ton of empty space. The fact that some of the particles deflected at an angle meant they must be hitting something of substantial mass. And since the alpha particles are positive, the inside part of the atom, the middle or the center, which we call the nucleus, must also be positively charged. Because we know positive repels positive. And the last thing is that since some of the particles actually came right back towards the lead box, that means that the mass is all inside that nucleus of an atom. So if we look on the next slide here, I put all of his findings. So you might want to pause or take a moment to write all these down. Okay? A lot of things were found from Rutherford's experiment. Okay? There is something inside that gold foil, inside an atom, that must be solid or massive enough to deflect a particle. So we know that there's something inside there with a lot of mass. That something that it's hitting must also be positively charged because it's repelling the positive alpha particles. It must also be very small because if you remember correctly, most of the particles traveled straight through the gold foil, not being deflected at all. So that something that it's hitting is positively charged and massive. However, it is small in size. And they called that dense center a nucleus. So here's your center of an atom, positively charged nucleus. And last but not least, Rutherford's final conclusion is the most of the atom must be empty space. Otherwise, all those particles would not have gone through. Have a great day. Go Pirates.